going to attempt to measure happiness in this chapter. So, chapter 20. Measuring happiness. So economists call a notion of happiness, it's not maybe quite the same. I think some people would argue it's different, and they're probably right in the sense of what your utility function is. So utility is the total satisfaction derived from consumption. The total satisfaction derived from consumption. So it's kind of weird. We're going to put a number that reflects your subjective evaluation of it. So we're going to use a number to measure your subjective well-being, happiness, I'll put in parentheses. I like to just kind of use the word happiness. But, so we're going to use that number to measure your well-being or your happiness. Okay, so let's take an example here. So example. Suppose we got 4 different bundles of goods. So we got 4 bundles of goods. So bundle number A. Bundle A has, and this is going to be with, I don't know if I need to write this, but pizza, beer, and M&Ms. So that's our bundle of goods. We got 3 goods: pizza, beer, and M&Ms. And so bundle A is going to have 4 pizzas, 2 M&Ms, and 5 beers. Bundle B is going to have 3 pizzas, 4 M&Ms, and 7 beers. Bundle C is going to have 2 pizzas, 3 M&Ms, and 10 beers. And bundle D is going to have 6 pizzas, 3 M&Ms, and 5 beers. Oops, I didn't want to do 5. Let's do 6. Okay, so I want you all to look at those bundles and rank them according to from your most preferred to your least preferred. So rank the bundles according to your preferences. According to your preferences, from most to least preferred. And so, for example, you're just going to go, oh, I haven't even really looked at these numbers, but B, A, D, C or something, right? So you just put the first letter. This is your most preferred bundle. This is your least preferred. So I'll give you a minute here to think about the quantities of each bundle and what's in each bundle, and then list your preferences, and then I'm going to randomly select a handful of you to share your work. Share what your answers are. So most preferred to least preferred. Which one is it? Okay, so Donnie, how about a number between 4 and 8? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. Come on up to the board. Write your first name only, and then put your ordering down. So right to the right here, just put your name and your order. And then you can go grab your seat. Yeah, to the right. Yep. First name and then your order that you came up with. Okay, so we've got 2 people with D in their first position, and then we got 1 with C and 1 with A. Interesting. Okay, so we got different variety going on here for first position. So I guess for one thing it highlights is that people are different, right? We all have different preferences for things, and that's part of what makes the world go round. So that's good. You guys had exactly the same thing. So let's take this. Oh, okay. All right. So Tucker and Patience. I think we're gonna kind of start with you. So Tucker, with you first. I want to arbitrarily say that bundle C gives you 100 units of happiness. So I'm just picking that one out of the air, okay? So let's just assume that bundle, your most preferred bundle is 100 units of happiness. I want you to tell me, what's your number for D then? We know that it's less. Is it a 90, an 80, a 70, 60, 50, 5, 3, 25, 30, anywhere really between 0 and 100. How does bundle D rank for you relative to C being at 100? 8. All right. Okay, so, and then what about B? Where does it fall to for B? Kind of give your numbers another look here.
Not much lower.
Not much lower. Give me a number.
I'd do 70.
70. All right. Patience. You've also got 100 here. And what do you rank D as? Your second choice. What would be your number for D? Anything between 0 and 100, just kind of relative to A being your most preferred. What would you put a number on for D? 80, okay. And what about for B? Could be, whatever you're feeling. Look at your numbers. Look at, so we go from 6 pizzas, 3 and 6 to 3, 4, and 7. So what do you put B at? 60, okay. All right, so what I want to do here is that I want to think about the step down here. Does Tucker like bundle B more than Patience likes bundle B? You see how we go 180, 180. So they both gave an 80 to bundle D. Tucker jumped to 70 for B. Patience went to 60. Can we say then that Tucker likes B more than Patience likes B? Would that be fair? Who said no over here? Okay, why?
each one has different satisfaction from the each bundle.
Okay.
You like ranking them different from.
Yeah, each person's different. Now, would it be fair to say that Patience likes B 40% less than what she liked A? Would that be okay? And same thing for Tucker. Would it be okay to say that he likes B 30% less than A? Yes. So we can use these numbers to get some information, let's say, within a person, but we can't make interpersonal comparisons, right? So what we're getting into here is consumer choice. What kind of drives the consumer? And so we start off with, well, what are the motivations for purchases of different things? And this is where we start off with consumer choice. We make the assumption that A, you are able to rank your preferences. And you guys just proved that. 4 of you came up here, and hopefully the rest of you did it too. Human beings are able to rank their preferences. It's not like we just sit there and go, I don't know, one day I like this, and the next hour I like this, and then sometimes I might switch or whatever, right? You have some preferences that have some longevity to them, right? You guys know if you like the sweets and chocolate of M&Ms, or if you're beer, if you're anti-alcohol, or if pizza's got too many calories, or it gives you heartburn, whatever the case is, you've got all that down. And so this is kind of our first step for utility in deriving these numbers. Okay, so I want to imagine, wait, I want to summarize that first before I imagine something new here. So, key point. Consumers can rank preferences, and numbers can be assigned to them. So we can do that, and then kind of our highlight here, number 1, it allows us to make to gain some quantitative knowledge within the person. So we can use numbers quantitatively within one person. And I'll write number 2 up here just because I know I'm running out of room down there. Number 2, we can't use numbers to compare happiness across people. Doesn't make sense. Okay, so let me go back to Kathy for a second. I guess I erased Chase, but Chase you had, so okay, this is Kathy and Chase, since you guys had the same thing. Kathy, why D over A? Okay, so A has less of the things you care about, meaning M&Ms? Okay, and so we got the most pizza here, and you're a pizza lover. Okay, so we also were able to see some of the preferences come through that way, right? So that we can see how much each person, the types of goods that they prefer through that. And we had C for Tucker. What was your C? What was your leading thing for C? I think I have a suspicion, but I want to hear you say it. Okay, so we got a heavy, he's thirsty, right? I mean, this is just food, and so it's the only drink available, and you got to drink what's in front of you, right? So isn't that some sort of rule? So, all right, so we got that, and then patience What drove your answer for A? What was your driving thing for A? Louder? The pizza. All right. So now, I want to look at this a little bit more carefully with you. So, if you like pizza, why not D? Like Kathy did, and Chase presumably. There was what? Too many M&Ms. So M&Ms repelled you from that? Yeah. Okay. All right. I can maybe live with that. So do you have an allergy to chocolate, or they give you anxiety to look at all the colors on the table, or if you just made a mistake, it's okay too, by the way. Candy's too much. Okay. All right. So here's the thing. We're going to allow you to not have to consume it. With property rights, patients, would this help you to know that you could have given this away to your friends? Yeah. And not eat it yourself? Yeah. Would that have helped? Okay. So that's another thing that we can do, right? And so sometimes going through these little, examples or experiments, the one that I wanted to point out the most was that more is preferred to less. So with clearing up patients' aversion to M&Ms, but knowing she could help out her friends maybe, or just not have to eat them at all, she could get 2 more slices of pizza and not have to do anything with the extra M&M. That would have helped too, right? So number 3 here is that more is preferred to less. More is preferred to less. And then we'll put in parentheses here for patients and you guys to say, you don't have to eat it or drink it. You can throw it away. You can destroy it. Just because I didn't want to write throw it away. Destroy or give it away. It's your property, right? So our property rights concept of when you own property, it comes with more rights to it. Nobody's going to force you to consume it. All right. Okay, I think that's probably fine for what we're doing here. So any last questions or comments?
I can't understand the ending of the first one.
This one here?
No, the one at the bottom.
Right here?
Yeah,
So use this number quantitatively within the person.
Okay,
Within on person, yeah, that's kind of goofy, isn't it? What did I put there? Within, I don't know what I was doing here. So within a person. So the example was Tucker likes, what was Tucker here? C, 30% more than B. Tucker likes C 30% more than B. All right. So now I want you to imagine mowing the lawn or doing some other activity. If you haven't mowed a lawn before, I like the lawn mowing example. So it's one of those super hot Kansas August days, 105 degrees, 80% humidity, and you have to go mow the lawn, right? And so you're out there for 45 minutes, you're dripping wet with sweat, you open up the refrigerator, and you grab your favorite beverage. And you take that, and you take that first gulp. And then you're like, wow. And then you take your second gulp. How does your second gulp compare to your first gulp? Which one was better? First one, right? That first one hits your lips, and it's amazing. The second one, might be close, I don't know. But how about the third gulp compared to the first or second gulp? Is it getting better as we gulp more? The third gulp, the fourth gulp, the fifth gulp, the sixth gulp. So what we have is this law, another law. We have the law of supply, law of demand. So there's an important law here with consumers, and that is the law of diminishing marginal utility. So as you consume more and more of a good, the happiness that you get from each additional unit eventually falls, right? And so that concept of human behavior we want to capture, because that's very important in terms of ultimately creating the demand curve and how many units you're going to buy. So let's first of all define marginal utility. Marginal utility is the utility derived from an additional unit of consumption. So from a formula standpoint, the marginal utility is equal to the change in total utility from another gulp, from another slice of pizza, from another cookie, from a, whatever we're consuming, it's the change in an additional unit when we use the word marginal. So let's kind of write our example. Hot, humid day, mowing the lawn, and compare gulps of favorite beverage. On a day like that, for me, it's beer. So, first, I should say rust beer. I'll reveal some of my preferences. Natty Light if you want to be exact. So. Number one, so basically the first gulp, the second, the third, the fourth. So we compare each unit of consumption and we come up with an important law of economics, the law of diminishing marginal utility. All right, and this goes something like this. So as you consume more and more of a good, the utility derived from each additional unit eventually, it doesn't have to maybe right away depending on the good, but it eventually declines. Okay, questions or comments on that?
Can you run us through some, like, math problems themselves with the equation?
We will,
Okay.
but not yet. So, what does this look like graphically? So if I measure beer here on the horizontal axis, and I'm measuring utility, so we're measuring utility here, not dollars. So we're measuring happiness here, and units of beer here. What do you think this utility function would look like? Is it upward sloping, downward sloping, starting from the origin here of 0, which means 0 beers, 0 happiness? Is it upward sloping, downward sloping? What do you think? Upward sloping or downward sloping or straight line? So it could be this, could be this. Tim? Downward sloping. Okay, is the total utility? So as I consume more beer, what's happening to my happiness? So going up or down? As I consume more beer, just in general, my happiness is, Seth? Oh, that was you were good. You weren't really raising your hand, just giving the old up arrow. It's going up. So some of you might have been thinking we were playing off of the marginal utility thing. I'm going to come back to that, but I don't want to overlook that as you consume more stuff, yay, we get happier, right? More time on my screen, more time consuming beer, more pizza, more cars, more shows, more whatever. So more is preferred to less. And so does that function, do you think, look like this, this, or this? A, B, or C, all of those are upward sloping. So as I consume more beer, I'm getting happier. According to this law, what would it most likely look like? A, B, or C? Let me go, Valentine. C, right. So we're going up, but at a diminishing rate. So we're increasing, but at a decreasing rate. So the law of diminishing returns says we'd have an upward sloping total utility function, but it would look something like this. So this is the total utility that I get from consuming beer. And now I'm going to make it kind of chunky here. So 1, 2, 3, 4 beers. 1, 2, 3, 4. When I consume my first beer, maybe I get 100 units of happiness. The second beer, my happiness climbs to 150. My third beer, I get up to 190. And my fourth beer, I get up to 220. And this is a way we can kind of capture this idea of the marginal satisfaction. The first beer gave me how many units of satisfaction? 100, which is the area of this rectangle, right? Area of a rectangle, base times height, 1 times 100 is 100. How much did the second beer give me? 50. So my total went up to 150, which added 50. What was the marginal utility of the third beer? 40. So the three beers, I gotta be, so kind of hang on to my words here. I try to be careful, maybe I screw up every once in a while. 3 beers, a total of 3 beers, gives me 190 units of satisfaction. How much did the third beer give me though? How much? You can shout it out. 40. So we've got from 150 to 40, we added 40. And then finally the fourth beer, we go up from 190 to 220, which gives us 30. And so these green boxes are getting smaller as we move along and accumulate beer. That physicalness getting smaller is capturing the law of diminishing marginal utility. Okay, questions or comments on that? Okay, so now we might get back to what some of you were thinking here. So if I'll just draw a little bit smaller graph this time. So we got beer still. And 1, 2, 3, 4. This time though, let's measure marginal utility. It's still utility, but I'm just going to kind of make it explicit that we're measuring marginal utility on this graph. The first beer from over here gave me how much? The first one? 100. So the first 1, 2, 3, 4, we get 100. And so that is 1 point. Second beer gave me 50. Third beer gave me 40. Fourth beer gave me 30. What does that thing look like? What else? What other curves have we talked about so far in class that has that shape? Downward sloping something. What thing did we have in chapter 3? The most important chapter of the book. What had a downward slope to it? What was it? Demand, right. So the demand curve has that slope to it. This is the marginal utility function, but it also is now giving us insights as to why people pay less when they buy more. They pay less when they buy more because of the law of diminishing marginal utility. I'm not getting as much happiness from the fourth unit compared to the first unit, so I'm not going to pay as much, right? So when we put dollars up here, we get that demand curve. So note, part of the reason we get this downward sloping demand, so downward sloping demand comes from the law of diminishing marginal utility. There's a connection here between our happiness and the amount we're willing to pay. So connection of utility, our happiness, and our willingness to pay. And in general, remember our willingness to pay, we were reflecting in benefits. So this was our, you might even say, marginal benefit curve. The MB curve is the demand curve. So where we, last chapter and the first time, demand curve is reflecting the benefits that you get through the dollars you're willing to pay. Now we're just tying it back to this little more abstract concept of happiness is what's driving that. Okay, questions or comments there? All right, so now let's continue on with making decisions. So we're going to make a table of numbers. Look at our buying decision.
The downward sloping one, that's supposed to be MB or D?
No, MB, MU, MB, and D are all downward sloping. So marginal benefit and demand are one and the same. And the utility function, so it's what's key here is what we're measuring on the vertical axis. We're measuring happiness here, utility, whereas these are measuring dollars on the vertical axis. All right, so so let's see here. Suppose we got beer and pizza. Beer and pizza decisions. So on this axis, we're going to measure the quantity of beer 0, 1, 2, 3, 4, 5, and 6. And then we get the total utility from beer. So now we got our schedule goggles on here. 0 beers, 0 happiness. 1 beer, 40. 2 beers, 60. 3 beers, 70. 75 for 4. And then things go downhill. 73 and 63. Otherwise known as driving the porcelain bus. Potentials. Maybe you're not quite there yet at this point. You're just making a fool out of yourself. Okay, so marginal utility of beer. So we got kind of undefined. What is the utility derived from the first beer? What is the utility derived from the first beer using those numbers? Now, this is a new example. There's nothing connected here to the old one. Tim? 40. So our total again, so you guys are getting some exposure, right? We did graphing goggles over there. Now I'm asking you to put on a set of what I call schedule goggles, right? There's a schedule of numbers here. And so when I go from 0 to 1 to 2, how much am I increasing my utility by? So I'm getting 40 units of happiness from the first beer. What about the second beer? 20. Third beer? 10. So we're just jumping from here to here. The fourth beer adds 5. And then what happens here? The fifth beer, minus 2. So we just drop negative. And minus 10. All right, then we got the quantity of pizza. We're going to keep the numbers easy here. So 0, 1 through 6. 0, 1, 2, 3, 4, 5, 6. But this is now slices of pizza. And your pizza meter, the total utility you get from pizza, is 0 if you have no pizza. Then we go up to 20. 2 pizzas gives you 34. 3 pizzas gives you 44. Then we go up to 50, 54, and then we end with 57. And then let's look at the incremental gains we get from additional slices of pizza. The first pizza gives me 20. The second pizza gives me 14. So I go up from 20 to 34, and that gives me 14. 34 to 44 gives me 10. 44 to 50 gives me 6. 50 to 54 gives me 4. And then finally we end up with 3 more for the 6th pizza. All right, so first of all, do these numbers for beer and pizza follow according to the law of diminishing marginal utility? How do you know? What's going on that you could quickly look at a homework problem or a test problem, which this could be on your midterm? How would you know? Give me your name again. Nick.
Because it's going up, but just
Okay, so and when you say going up, you're saying this one's going up, but these are actually going down, right? So these numbers going down, a quick glance means we've got the law of diminishing marginal utility is in place here. It's not violating the law of diminishing marginal utility, which then we'd kind of throw the answer out or it wouldn't make sense. Okay, so now if pizza and beer are free, what would you consume? If this was your options through all the way up to 6, what combination of beer and pizza would you consume if this was your preferences? What would be the utility maximizing level of beer and pizza? Yeah. 4 and 6, right? Might as well max this out. This was still going up. And so I would maximize my happiness by choosing to consume 4, because this one's maxed out at 4 and 6. All right, what if this stuff costs money? So real life, we have a budget. So the budget constraint. This is an amount of money. I'll put parentheses your income, sometimes we use that word. An amount of money that is to be spent on the goods. So for this example, let's assume that your income is $10. The price of beer is $1, and the price of pizza is $2. So you got $10 to spend. So, what do you buy first? What do you spend your money on first? Beer or pizza? Where are you going to spend money first? Valentine?
Beer.
Beer. Why?
If it goes higher directly.
Yeah. So we get 40 units of satisfaction. So what we're trying to do, our problem, so let's say the consumer's problem, is to maximize happiness, total utility, which is equal to the total utility from beer consumption plus the total utility from pizza consumption. So basically, I want to make myself as happy as possible. And so my first choice would be my first beer because 40 is greater than 20. What do I consume next? My second beer or my first pizza?
Whatever.
Whatever. So because 20 and 20, what do you think? Tim?
Because it costs less.
All right, so we didn't take price into account. So how much, what we want to do is kind of think, well, where am I getting a bigger bang for my buck, right? Have you guys used that lingo before? Kind of where do I get the biggest bang for the buck? And so I'm getting 20 here and 20 here, but I'm having to spend $1 to get 20 here, whereas I got to spend $2 to get 20 there. So we're going to correct for that and add one more column over here. The marginal utility of pizza divided by the price of pizza, which gives me my per dollar utility. So for my first pizza, I'm actually getting $10, right? 20 divided by 2 equals $10 of happiness per dollar spent. Does that make sense? Yeah, Tim?
What is that? MAUP.
This is MU. Marginal utility. So I just took this number, divided it by the price. So 14 divided by 2 is 7. 10 divided by 2, 5. 6 divided by 2, 3, 2, and 1.5. Now it happened to be that beer had a price of $1, so it's already it, right? So this is really, if you wanted to put by the price of beer, the marginal utility divided by the price of beer, these numbers end up being the same. With that in mind now, second beer or first pizza? So now we want to keep our eyes on this column here. Second beer, good. Third beer or first pizza? Way back, yeah, give me your name again. Anthony. Third beer. Why? Okay? How many people were thinking pizza? So the happiness level for the third beer is 10, but the first pizza is 10. So what does that mean? Doesn't matter?
You now take pizza because it's that one never happened.
So there's another little known law in economics called the Russ law. And basically, when it comes down to a tie between beer and pizza, always go with beer. So now, the next one would be the fourth beer or the first pizza. Fourth beer or first pizza. Nice and loud. You guys can start shouting this. Hopefully you're starting to get it. First pizza, right? So now we definitely go with the first pizza. Now let's take a step back. How much money have I spent? I've got 3 beers under my belt and a slice of pizza. $5. So $3 plus $2 is 5. I can keep going. Fourth beer or second pizza? Second pizza. Fourth beer or third pizza?
Go with beer.
Russ law kicks in. What's your name?
Huh?
Yeah.
Zach.
Zach. And what do you say?
I was gonna say beer, shouldn't have $1 left.
No, we got more money than that. So this is $4, this is $3, we got $7. We got $3 left. So third beer or third pizza or fourth beer, they're equal. Russ law kicks in.
Yeah, it was before beer.
There. Hopefully you guys know I'm kidding. You're indifferent between the two. Like you say, it doesn't matter. You're indifferent is what we call it. All right, so then finally your fifth beer or your third pizza with your last $2. All right, now we're on our third beer. All right, so what we've done is we have, by selecting the thing that gives me the maximum bang for my buck, I have successfully maximized my utility subject to my budget constraint of $10. So I did this, right? The consumer's problem is to do this. And so the key is to choose the optimal quantity of pizza and beer where the marginal utility of beer divided by the price of beer is equal to the marginal utility of pizza divided by the price of pizza. Where this happens, you've successfully solved this problem. You've made yourself as happy as possible by always following this rule. And that's what you guys were doing when you followed the rule of, I'll take this one gives me more bang for the buck until the money's all spent. And that is the utility maximizing condition. This is, when you do this, you'll be maximizing utility. Okay, questions or comments there? Yeah.
Is there anything we could use to label the happiness ones, I guess, on the card, right?
On this one?
Yeah, like how we have NU.
We usually don't because your label is up here. Okay, we'll see you tomorrow. We'll pick up there, build on that a little bit.